Okay, students, so today I am going to discuss arithmetic progression. You can see theorem number 2. I already discussed one of the theorems. Okay, if you want to see that theorems, you should go through the description box. Okay, so please go through the statement. Prove that sum of n terms of an AP, which first term, that is the word A, and the common difference, that is D, and the last term is also is given by L. Then we need to prove here Sn equals to n by 2 A plus L, or Sn equals to n by 2 2A plus n minus 1 into D. Okay, so just I am going to prove these theorems. Okay, so first of all I will take the sequence of AP. So let A let the arithmetic progression. Okay, so I can write here A plus D, A plus 2D, and here is L, and after that L minus D, and before it L minus 2D. Okay, so this is the sequence, and now we are going to write what series. So series means what, we can write here, and here A is what, first term. We can write here A is the first term, which is already included in your course theorems. So T is the common difference and L is the last term. Okay, so if we add all of the terms, suppose L, let Sn equals to sum of n terms, means these terms, n terms, okay, of NAP. So we can write here what Sn equals to, like A plus D, A plus what, 2D, and up to L minus 2D plus L minus D plus what, L. This is the equation number 1. Okay, now we are going to reverse the sequence. As you know that if we will add 1 plus 2 plus 3, and if we will add 3 plus 2 plus 1, both are same. So therefore we can reversing the series. So we will get here, we can write here reversing the series. Then total sum means Sn is already constant, so that therefore we can write here L plus L minus D and plus L minus 2D. Okay, and after that we can write here that A plus 2D plus A plus D, A plus D plus what, A. This is the equation number 2. And now we are going to adding equation 1 and 2. Adding equation 1 and equation 2. So if we will add equation 1 and 2, we will get here Sn what, 2Sn, and here you can see A and A what, 2A. Okay, A 2A, and after that you can see here what, D minus D will be cancelled. Okay, and 2D will be cancelled. So therefore we can write here what, Sn equals to A up to n times. Okay, so A up to n times, and next is what, plus L up to n times. L is n times. So we can write here, if A n times, so we can write here 2Sn equals to what, Na, and here is L. So you can take common, what will be the common, please see. I think n is common, so we can write here n A plus L. Okay, n A plus L. So Sn equals to what, Sn equals to, we can write n by 2 A plus L. First part is already proved. So now we are going to discuss the second part. This is the already proof. Next thing that is you can put the value of L. Okay, you can put the value of L. Suppose L is what, L is A plus n minus 1 into D. as we know that the formula of n. So we can put here, so Sn equals to what? Sn equals to n by 2, and n by 2 plus l. L means what? Sorry, n by 2 plus a, and l is a plus n minus 1 into t. So we can write here Sn equals to n by 2 a to a plus n minus 1 into t. This is the result of this theorem, where Sn is what? Sn is sum of n terms, n equals to what? Terms, and a equals to first term, and n equals to term, and d equals to cohort difference. Okay, and l is the last term. So this is the theorem. Now we will learn the uh, application of this theorem in another video. Okay, so thank you so much.